Hi, in this video we finally begin to look at Python proper. When you activate Python, the first thing you're going to see is the shell. So the shell is this application here that allows you to communicate directly with the Python interpreter. So that's what I'm doing here when I say, for example, when I type 5 plus 3 and I press enter, the shell communicated with the interpreter, gave it the numbers 5 and 3, and told it, well, add those two numbers. The interpreter did that and gave us the result 8. In this sense, the shell is acting as not much more than a simple calculator. However, Python is much more. So the first thing we want to look at is how do we store values in the system. To do this, we use variables. So for example, I can say x and I write an equal sign, but this equal sign does not mean equal. If I say x equals 7, this is telling Python to associate the number 7 with the variable x. What is happening here is that when I click enter, the system, Python, will find a register or a set of registers and it will place the value 7. How it does that is of no concern to me as a programmer writing in Python. So this is what you have to understand, that when you're working with Python, you're working at a high level. How this translates into machine code and what's happening inside the computer, you need not think about that, at least not for this course. So I click enter and we see nothing, but we haven't gotten an error message, so we know that command was executed. What was the command? The command was to associate. We use the word assign. The number 7 was assigned to the variable x. So if I type x, we see 7. So I can say 3 plus x and I get 10. So this command is saying add the number 3 to whatever x is associated with. Of course, x is associated with the number 7, so we get 10. It's very important for you to understand the concept of assigning values to variables. This equal sign does not mean that x is equal to 7. For example, if I go and I say x equal 10 now, well, that's what x is associated with. So when reading this, you should never say x equals 7 or x equals 10. You should say x is assigned 7, x is assigned 10. It is important that we create some visualization of what we just discussed. So this red circle here is going to represent the memory that our Python works with. When you write x and assign the value 7 to it, what Python does is it creates what is called an object. So for now, think of an object as simply a chunk of memory, and this chunk of memory contains the value 7. You do not need to concern yourself with how the registers are accessed and what the system does to get that number into the physical memory. At this level, when you're working with Python, you simply need to think of this as the system associating your variable x, and it could be perhaps a better variable given the circumstances you're working in. For example, it could be mass. You could write mass or height. So we create this object with the value 7 and we associate x with that object. Now, if you subsequently type x equal 10, in other words, you associate x with 10, what happens is that this association is broken and x is now associated the object 10. This is how we want to visualize this. Now, if any of you have done C++, this is a slightly different visualization. When working with C++, you are closer to system memory and you would perhaps need to visualize this differently. But in Python, we do not concern ourselves with system memory at all. So we are only going to be thinking of this as an association between our variable and some object in memory. So X was associated with 7, and now it's associated with 10. Sometimes we use the word bound. So we can say X is bound to 10 or X is bound to 7. So sometimes you hear people saying, well, here we bind X to 7, here we bind X to 10. A bit more precisely would be X is bound to an object containing the value 10 or 7. Let's look at another example. Let's say I assign 7 to X and I assign 3 to Y. X is bounded to 7, Y is bounded to an object containing value 3. So remember, think in terms of objects. X is bound to an object which contains the value 7, Y is bound to an object which contains the value 3. What if I do this now? What happens if I were to type X and press enter? What would be the result? If I typed Y and pressed enter, what would be the result? Pause and think for a moment. Okay, so here goes. Let me type Y. It's 3. Well, that makes sense. Y was bound to 3. And how about X? If you said X would be bound to 3, you're correct. What happened here? X was bound to whatever Y was bound to. So make sure you understand this command. This is saying you're going to take X and bind it to whatever Y is bound to. Now if I were to go and say X equal X plus 1, and if I were to now say Y equal Y plus 2, well, now X is bound to whatever X was initially bound to, which was 3 plus 1. In other words, with this command, X is bound to the sum of whatever X is bound to and 1. So the machine finds what X is bound to, in this case 3, adds it to 1, and then binds X to that. Here, the machine goes and looks for what Y is bound to, which is 3, and adds 2 to that, and then binds Y to that new value, which is 5. So here we go. X is 4 and Y is 5. So let's visualize this and see what's going on here. In this case, we started off by assigning 7 to X and 3 to Y. So this is how we would visualize this. X is bound to an object containing the value 7, Y is bound to an object containing the value 3. Then we have this command. Now X is going to be bound to the object that Y is bound to, and that's what we have here. So now X is bound to 3 and Y is also bound to 3. Then we said X is bound to X plus 1, if I remember well. So now X will be bound to 4. Notice X is bound to 4 and Y is still bound to 3. Of course, we then said Y equal Y plus 2. So Y is going to be assigned to the result of adding 2 to whatever Y is bound to. So of course this is going to give us Y is bound to 3. So 3 plus 2 gives us 5, and so now Y is bound to 5. And so that's what happened. So when we typed X, we got the 4 that is now bound to X, and when we typed Y, we got the 5 that is now bound to Y. So make sure you understand this. It's very important. So far we've been using variables like X and Y, and here we have Z. Now these are horrible variable names. For example, I have X equals 6, Y equals 3.14, and then I have Z equals Y times X squared. So this is how we raise something to a power. So if I wanted to raise 6 to the 5th power, I would say X and then write asterisk twice, and then if it's the 5th power, write 5, 8th power, write 8. A single asterisk is simply multiply. And of course, if I do that, I execute that, and now if I want to know what Z is, I can see what Z is. Now, a program written like this would be almost impossible to read. In this case, you may have guessed what's going on here, but you shouldn't have to guess that much. I mean, you should be able to look at a program and follow it. So let's say I were to say radius equals 6 and pi equal 3.14. Then now I typed area equal radius times, that's pi rather, times radius squared. And now it should be a lot easier for somebody looking at this code to understand what's going on. So unless x, y, and z has some significance in the context in which we are writing some program, don't use x and y's. Use variable names that mean something in the context of what you're doing. So if you're writing a program to calculate the volume, call it volume. And if you're using the height and the diameter, call the variables height and diameter. Don't call them x and y's, because nobody, including yourself, will be able to understand your program. So of course, if I type here, we get the same answer. So this brings us to a very important point. It is not only important that your program run and that it be correct. Your source code has to be understandable. When you write a program, always think that you're writing it for someone else to read. Think of yourself as being someone else. Because after you write a program and you come back to it a few days later, very often you look at it and you have no idea what the heck you wrote. So always bear that in mind. As we go through this course, we'll discuss various aspects of programming that you have to pay attention to in order to make your programs understandable. It is impossible to write a meaningful program without making mistakes. And to find your mistakes, your program has to be well written